Let's go through the code 2749 minimal operations to make an integer zero. So it gives us two numbers, nums1 and nums2. It asks us what's the minimal operation to make nums1 to be zero. So one operation is that we can choose any I from 0 to 60 and subtract num1 by 2 multiply 2 power I plus num2 from number1, right? So ask the minimal times to get nums1 to be zero. If impossible, return -1. So let's look at the what we want, right? So the first time, if we have num1, nums2 equals 2 to power x, sum of the x, right? Then we return 1. The second round is if we have 2 power x plus 2 power y, right? Then equals n1 minus 2n2, right? Then return 2, right? So if we have, for example, 2 power x plus 2 power y plus blah blah 2 power l, right? If there are k combinations equals n1 minus k n2, then we terminate at k, right? So we just go through um, trying the first if so this round or this round, if we find the earliest time which can have this one equals, then we return the number, right? So we iterate k from 1 to some numbers, right? So the things that when can we terminate? Here there is the thing, right? So we'll say if we'll say this is let's say this is x, this number is x every time we iterate. This is x, right? So we'll say if we have this x is smaller than k, right? For example, this number is smaller than 2. Then we cannot write to any number as 2 power x plus 2 power x plus power y, right? Because the minimum of this is 2 to the power 0 to power 0. That is k, right? So if this is already smaller than k, so if this x is smaller than k, right? Or we'll say k is smaller than x, uh, then that means uh, it's impossible because the minimal of this one will be k, right? So the minimum is set all of that to put up to the power 0. And also if we have k, um, for example, smaller than the number of bits, for example, this number, right? This is I would say this is x, right? If k is is smaller than number of bits of x, that means um we are we 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 are not able to put this one equal as well, right? The reason is that we need at least k number of 2 power something because there are uh um let's say this is a bit count. So we need at least a bit count of 2 power something to add, right? Because for example 1101, right? That means we need at least 3 of the 2 power something to add. We can more than 3, right? Because we can separate, for example, this one as 0, 1, 0, 2 of 0, 1, 0, right? And so we can as long as this k is greater equal to the bits of x, we are able to make this one as the sum of the k of the uh, 2 power something. But if this k is smaller than the number of bits of this, it's still impossible, right? So we should still continue. So our termination condition is that if k is greater or equal to this number's 1 bit, and it's smaller equal to this number, right? Then we find a k. So that means if we have this k is greater or equal to the bits or bit count of this number, and also smaller equal to this number, right? Then we find a k. So we just have this logic, then write the code. Let's write our code for this. So we'll have int k equals 1, right? So what we have is y true. So we need to have long, right? Because number 2 may be negative. So let's use this as long. X equals num1 minus 1 multiplied by k multiplied by num2, right? So k plus plus. So when should we terminate? That is, we'll say if k is greater, if k, for example, greater equal to we'll have long bit count. X, let's say, and k should small equal to this k x, right? Then we just return k. In the end, if we are not able to let me see, k, for this k, if we can terminate earlier, right? We can write if k is greater than x, just return -1, right? And if this one is greater or equal to the bits of this number, then we return k. That means we can always put this one as the sum of the k to power something. So this will be the code, right? And also we have the Python code for this. It will be similar. So we'll have k equals 1, while 2 we'll have x equals num1 equals k multiplied by num2. So we'll say if k if we have this kind of k is greater than x, it's impossible, right? Because what we don't have a so because the worst case is that we have all of the 2 power zeros, and for this x, it's not big enough already, right? Just return -1, and we'll say if k is greater or equal to binary x count 1, right? Then we just return k. And every time we'll have k should plus equal to 1, right? And we are counting the actually every time we do the operation, right? So we are counting the bits. This is some kind of log operations. So it will be log n1 time complexity in the O1 space.